Hello everyone, welcome to the next lecture. Myself, Professor Neha Sharma from Department of Computer Engineering, Kesav Institute of Engineering Education and Research, Nashik. We are NACE accredited and NB accredited for 8 branches. In this particular lecture series, we are going to study one of the courses from T Computer Engineering 2015 syllabus of Savitribai Phule Pune University. The course belongs to semester 2 of third year, and the name of the course is Design and Analysis of Algorithms. In this particular lecture, we are going to study one of the topics from unit number 1, and the name of the topic is Iterative Algorithm Design Issues. So before we move on, let us first understand the objectives and the outcomes of this particular lecture. So the objective of the lecture is to understand the iterative algorithm design issues, and at the end of the lecture, we will be able to design efficient algorithms taking care of these iterative algorithm design issues. So now let us start. What is the cause of iteration? Whenever somebody asks this question, what exactly comes to our mind is two things. That is, the term iteration means doing something again and again and again, right? So in our algorithm or in our code, when iteration comes, that comes because of two things. What are these? First is because of looping construct. That is, in our code or in our algorithm, we make use of loops like for loop, do while loop, and so on and so forth, right? Another possible cause of iteration is recursive algorithm. That is, you are calling the same function or procedure again and again. Okay, so that is a cause of repetition or iteration, right? So when we are designing an algorithm, these iterative components play a major role, or they are the major contributors to making your code either efficient or inefficient. Means what? If you take care of these iterative components properly, then you will be able to write efficient algorithms. And if you don't do so, then your code will possibly be inefficient. Okay. So in this algorithm, we are going to see the iterative algorithm design issues. First is the use of loops. Okay. So whenever we talk about loops, we know that whenever we write any looping construct, it consists of three components, which are these: initial condition, invariant relation, and termination condition, right? So we will see each one of them, how to write these conditions, how to write these components of the loop. Initial condition. So that is the first thing we write in any looping construct. So how to write initial condition correctly is we must set the loop control variable to values appropriate for solving smallest instance. Means what? We usually set the value of initial condition to the smallest value. Okay, that is, if we are using a loop control variable as I, we usually set the value of I to 0. That is the smallest possible instance or the smallest possible value. Similarly, if you are writing an algorithm for calculating the sum of n elements of an array, then you use or you set the initial condition of the variable s to 0. Okay, so that is how ideally you should use the initial condition or write the initial condition inside the loop. Then second one is the invariant relation. Okay, now what this means is, once you have set the initial condition, then in invariant relation, what we actually do is we take it to the next level. That is, from initial condition, we try to extend smallest problem to the next smallest, then next smallest, then next smallest, and so on and so forth. So invariant relation, how you will write? Initial condition was I is equal to 0, so invariant relation will be I is equal to 1. Okay. Similarly, for s is equal to 0 as initial condition, the next invariant relation would be s is equal to a of 1. Okay, or simply s is equal to s plus a of I. Okay, so that is you are taking it to the next level or the next step, then plus 1, then plus 1, then plus 1. It could be also minus, minus, and so on and so forth, but you are taking it to the next level, that is the invariant relation. Then third one is the termination condition. Okay, how you should write the termination condition. Now we have seen in the characteristics of algorithm is your code is, you can call the code that you have written as an algorithm if it can terminate in finite number of steps, right? So when similarly when you are writing in a loop, then you should properly set the termination condition. That means it should be clear when you are moving or terminating the loop. When you are moving out of the loop or when you are terminating the loop should be very clear. Okay, let us see a few examples for this. First example is a for loop. For I is equal to 1 to 20, do some statements inside the for and then end for. Okay, so in this we know that initial value that I will take is 1 and it will go up to the value 19. Okay, and then when I becomes 20, then we will move out of the loop. Okay, so this is fine. This is second for loop where I ranges from m to n. Okay, this is also fine because you know that initial value that I will take is n and the last value that it would take is n and then it will terminate, right? But if you write something like this, the third example is of a while loop. So inside the while you are setting two conditions, while x is greater than 0 and x is less than 10, do some statements inside the loop and then end of the while loop. Okay. Now in this, we cannot be sure about when exactly the loop is going to terminate. Why? Because that depends on the value of x. Okay. In the first condition, it is saying that you should continue iterating the loop till x is greater than 0. The second, x is less than 10. So it all depends on what is the value of x, what kind of statements you are writing inside the for loop, it also depends on that. So we cannot be sure about when exactly the loop is going to terminate. It may also, you may also end up iterating inside the loop again and again and again infinitely. Okay, so such type of statements like the third one, you should avoid writing inside your loop. Okay, so ideally as a termination condition you should write loops such that it is very clear when the loop is going to terminate. So that was the first iterative algorithm design issue, which is use of loops. The second one is efficiency of algorithms. Second design issue is how to write efficient algorithms. So whenever it comes to writing algorithms or writing any code, we know that whatever we are writing, it will actually execute on your system or on the computer. Okay, so it will consume some amount of resources available on the computer. So when we talk about resources, majorly we are talking about two kinds of resources, time and space, that is CPU time, and internal memory, that is RAM. Okay, so we should be able to write algorithms so as to make efficient utilization of these resources, and you must also understand how to improve the efficiency of the algorithms that we have written. So there are basically four ways to do this, which we are going to study. First one is removing redundant computations outside the loops. Second one is referencing of the array elements. Third one is inefficiency due to late termination. And fourth one is early detection of desired output conditions. Now we are going to see each one of them in detail one by one with examples. So the first one is removing redundant computations outside the loop. So just check the algorithm that is available on your screen. Okay. Now in this algorithm, here we are using an initial condition. Can you do anything about it? Can you, if you check this algorithm, is there any way you can improvise or refine this algorithm so that it becomes much more efficient? Let us check that statement by statement. first is the initial condition. You cannot do anything about it. You cannot change it, or there is no other way in which you can write this so that your algorithm becomes much more efficient. So we skip this. Second is a for loop for I is equal to 1 to n do. So that is also a for loop written correctly. So we cannot do anything about it. Inside this, we have an arithmetic expression for variable x. X is equal to x plus 0.01. Okay, so depending on the value of x, okay, we are changing the value of x here. Okay, then next is an expression for y, which is a3 plus c into x square plus b square into x, and at the end we are printing the value of x and y. Okay, and then we are ending the loop. Okay, so we want to improve this algorithm in such a way that it becomes much more efficient. So we cannot do anything about the first statement, about the second statement, about the third statement, and about the print statement. Okay, but if you observe this statement, it involves certain components that we can take care of. What are those components? If you check this part, okay, this entire expression, if you take and initialize it in some variable outside the loop, much of the computation would be reduced. Similarly, you observe this part, it involves a variable b, okay, which is not involved anywhere inside the loop. Okay, so this b into b also you can take and initialize it inside a variable outside the loop. Okay, so how to do it? Just check the variation of the code, which is much more efficient. Okay, so what we have done here is, you can see this a3c. So this variable we will initialize to a into a plus c outside the loop. That means here. Okay, similarly this b into b. Okay, so variable b2 is equal to b into b. This initialization we will make here outside of the loop. So what will be the advantage of doing so is, instead of writing y is equal to this entire thing, we can write y is equal to a3c into x plus b2 into x. Okay, so this initialization we have made once inside the loop. So again and again, you need not do the same computation of a into a plus c. You need not do b into b again and again n number of times. Why? Because we have done this computation only once outside the loop. So directly its value will be used here. Okay, so that is how you can improve the efficiency of algorithm by removing redundant computations outside of the loop. So that is the first way of improving efficiency of the algorithm. Then second way is using uh, array elements, proper references of array elements. So on the screen you can see two variations of, sorry, yeah, on the screen you can see two variations or two versions of the same algorithm, that is they do the same thing. And if you just observe, you will be easily able to identify that both the versions are used to find out the maximum element or the largest element from the given array, that is A. Okay, so if you just observe the two versions, what do you think, which of the two versions are efficient and why? We need a justification for that. So I will just give you a few moments. Just have a look at the two versions and tell me which of the two versions is efficient and why. In the first version, we are using two array references. In the second version, we are using a single array reference. Okay, and the topic is related to referencing of the array elements. Now remember, whenever you are using an array reference, that means you are using the concept of indexing. Okay, so here you are indexing the array twice. That is, you are using two array references, once for a of I, another time for a of p. So two array references are used at the same time here in the first version, whereas in the second one you are using a single array reference. Okay, so this second version is much more efficient because it uses a single array reference, and using array references is a costly affair. So you should write algorithms in such a way that minimum array references are being used. Okay, so that is how you can improve the efficiency by using minimum number of array references. So this version is much more efficient as compared to the first version. Undoubtedly, or no doubt, both of them give the same output, which is correct. But still, when it comes to efficiency, this second version is better. Okay, so that is the second way of improving the efficiency of the algorithm. The third one is inefficiency due to late termination. Okay, now to explain this point, let us consider an example of, let's say we are given with an alphabetically sorted list of names of people, and along with that we are given with a particular name that we have to search whether it is available in the list or not. Okay, so for this, let us say we write two versions of the algorithm. In the first one, we are using a while loop. While name sort means the name that you are searching is not equal to the current name wherever your pointer is. Let us say your current name is the first name. Okay, so it's not equal to the current name, and it is not end of the file also. End of the file means here end of the list. Okay, do get the next name from the list. So if you check this first version, it is easy to identify that first version indicates sequential searching, right? So you compare the name that you are searching with the current name. If it's not equal and not end of the file, you take the next name, compare it with that, you take the next name, compare, and you continue this process till the end of the list. Okay, let us check the second version. In the second version, we are checking while the name sort is greater than current name and not end of the file do get the next name from the list, and we are also testing if current name is equal to the name sort. So if you just observe the second version, you will be able to easily relate the second version to the concept of binary search, right? Okay, so what we do in binary search is when we are given with a sorted list and we want to search something in the sorted list, we compare it with the middle element. If it is matched, then we return the position. If not matched, then we simply check whether it is greater or smaller than the middle element. If it is greater than the middle element, we completely skip the first half of the list, and we only search in the second half. And if it is less, then we completely skip the second half and we only search in the first half. Okay, so you can easily comment that the second version is much more efficient, because if you are using this kind of code, then your algorithm will terminate when it is supposed to be. Here, your algorithm will not terminate whether the name is there in the list or not there in the list. It will still go till the end of the file, right? So that is inefficiency caused due to late termination. Okay, so you know already, right, that your list is already sorted. So there is no point in searching something that starts with B, and if you have already crossed B, then there is no point scanning the entire list because you know that it will not be there in the list, right? Okay, so that is inefficiency due to late termination. And now the last way in which you can improve the efficiency of the algorithm is early detection of desired output condition. Okay. Now for this, let us take an example of bubble sort. I hope everybody is aware of bubble sort. So this is the first version and most generalized version of bubble sort that probably we all have studied so far, in which we are using a variable I and initializing it to n, and we are using two nested for loops. The first for loop is with a variable I from I is equal to 1 to n minus 1, do. For j is equal to 1 to I, do. Inside that, we are comparing the current key with the next key. That is, we are comparing the first and the second element. Okay. If it is greater, then we exchange the elements. Okay. If it is not, then we simply go to the next value of j, take the next value, take the next value, take the next value. And then we again increment the value of I and repeat the same process. Okay, so this is how we usually write the algorithm of bubble sort. Okay, the code is fine, the algorithm is fine. Now, let us say, for example, the input that is given to us for this particular algorithm of bubble sort is already sorted. Okay, the input given to us, the input given to this algorithm of bubble sort is already sorted. What will happen? You will still go here, 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 and you will keep on iterating continuously, even though the list is already sorted, right? So, can you refine? Can you alter? Can you update? Can you modify this version of the algorithm in such a way that this situation can be handled? Then only we can say that the algorithm is efficient. So how we can do that? It is very, very simple. We just have to add a single statement inside the algorithm. What is that single statement? Just check. This part remains the same. Okay. Now, if suppose you're not making any exchanges here, that indicates what? The list is already sorted, right? So there is no point in repeating the steps if the list is already sorted. Okay, so what we will do is, what I have done here is, I have simply added this statement. What it says, if no exchanges were made during the above loop, then return. Return means you are moving out of the loop. Okay, if this is not so, then you go to the else part, I is equal to I minus 1, and then you go on repeating the procedure, right? Okay, so this, just by making this simple change in the code, the algorithm becomes much more efficient because it is capable of handling a situation wherein the input that is given to us is already sorted. Okay, so this is the fourth way of improving the efficiency of algorithms. So that is all for today's lecture. So in this lecture, we have seen the iterative algorithm design issues. It starts with the use of loops. We have seen how to write the three components of the loop, that is initial condition, iterative construct, and the loop termination. Then we have seen the second iterative algorithm design issue, which is efficiency of algorithms. Inside that, we have seen four ways of improving the efficiency of algorithms. The first one was removing redundant computations outside the loop. Second one was related to referencing of the array elements. That is, we should write an algorithm with minimum number of array references. Then third way of improving efficiency we have seen is, we should write the algorithms in such a way that it should terminate at appropriate time. There should be no late termination. So the third way was inefficiency due to late termination, in which we have seen the example of searching in a sorted list. And the last way of improving efficiency was early detection of desired output conditions. Okay, in this we have seen the example of bubble sort, and how just by adding a single statement inside the code or inside the algorithm, our algorithm becomes much more efficient because it becomes capable now of handling a situation wherein we are given a sorted output. Okay, so I hope till here it is clear to you. There are much more number of design issues that we will continue in the lectures. For this lecture, we have seen only two iterative algorithm design issues. First one was the use of loop, and second was improving the efficiency of the algorithms. Okay, so we'll continue with the iterative algorithm design issues in the subsequent lectures. So I hope you have understood the points that were covered in this particular lecture. If still you have any doubt, just feel free to drop your queries or mail me onngsharma@kkbank.edu.in. So Thank you so much for patient listening. We'll stop here.